linguistic constructions, translation methods based on neural networks. Introduction. Currently, one of the important problems in the field of natural language processing is the insufficiently high probability, adequacy, and speed of translation. This leads to the fact the natural language interaction of computer agents in multi-agent systems may be insufficient. Thus, the criteria of models and methods that increase the efficiency of using natural language constructs for the interaction of computer agents is an urgent task. Today, artificial intelligence methods are used to translate linguistic abstractions, while the most popular is the connection approach, which for many networks allows the use of parallel learning methods. Recurrent networks for translate linguistic abstractions. LV neural network, or simple recurrent network, bidirectional recurrent neural network, or short-term memory, bidirectional recurrent neural network, gated recurrent unit, bidirectional recurrent neural network. Purpose and objectives as a research. Purpose as a researcher is to develop a natural language construction, translation methods. Objectives as a researcher. Analyze existing methods of translation, propose neural network models of translation, propose a criterion for evaluating the effectiveness of neural network translation methods, create methods for determining the value of parameters of neural network translation models, perform a numerical study. Propose methodology. Modify neural network for translation. Figure 1 shows proposed to modify neural network, which is a recurrent network. The modified neural network includes an encoder and decoder. Unlike the classical neural network, there is no feedback from the output layer to the hidden layer in the decoder. Let us limit our consideration to the function in the n, in the case when the encoder and decoder are based on n. It is assumed that the text input sequence f1 has already been converted in encoded input sequence, for example, and the length of each encoded word as an input sequence. It is assumed that an encoded output sequence of the length will be converted to a text output sequence, and the length of each encoded word as the output sequence is equal to the number of hidden layers in the encoder and decoder is equal to n2 and 2 function is the insulation, calculation is the output signal for the hidden layer as the encoder, checking the completion of encryption, calculation is the output signal for the hidden and output layer as the decoder, checking the computation as the decryption, modified additive attention neural network for translation. Figure 2 shows proposed modified additive attention neural network, which is a recurrent network. The modified additive attention neural network includes an encoder, an attention mechanism, and a decoder. Unlike the classical additive attention neural network, there is no feedback from the output layer to the hidden layer in the decoder. The attention mechanism allows the decoder to pause attention of certain output as an encoder. Let us limit our consideration to the function as an n in the case when the encoder and decoder are based on n. It is assumed that the text input sequence f1 has already been converted to an encoded input sequence, and the length of each encoded word is the output sequence. It is assumed that encoded output sequence element will be converted to a text output sequence, and the length of each encoded word as the output sequence is equal. The number of hidden layers into the encoder and decoder is equal to n respectively. Functioning as a information, the calculation as the output signal for the hidden layer as the encoder, checking the computation encryption, additive attention, additive attention is used, which connects the encoder's hidden layer and the decoder's hidden layer. Calculation, weight, estimate of attention. Context calculation. A calculation as the output signal for the hidden and output layers as the decoder. Check the conversation description. Modify multiplicative attention neural network for translation. Figure 3 shows proposed modified multiplicative attention neural network which is a recurrent network. The modified multiplicative attention neural network includes an encoder, an attention mechanism, and a decoder. Like the classical multiplicative attention neural network, there is no feedback from the output layer to the hidden layer in the decoder. The attention mechanism allows the decoder to focus attention as certain outputs as the encoder. I wanted to limit our consideration to the function at the end, in the case when the encoder and decoder are based on. It is assumed that a text input sequence of length has already been converted to an encoded input sequence, and the length of each encoded word as the input sequence. It is assumed that the encoded output sequence of length will be converted to a text output sequence, and the length of each encoded word as output sequence is 2. The number of hidden layers in the encoder and decoder is equal to n respectively. The function of the evaluation, calculation of the output signal for the hidden layer and the encoder with the connection of all inputs. Checking the computation of encoder, calculation of the output signal for the hidden layer and the decoder. Multiplicative attention, multiplicative attention is used, which links the hidden layers as the encoder and the hidden layer as the decoder. Evaluation of weight, estimate of attention, multiplicative attention is general then. The multiplicative attention is done, and then context calculation, calculation as the output signal to the hidden and output layer as the decoder. Checking the computation of decryption. An additive attention neural network with function. In this paper, propose an additive attention neural network with an indication of oscillation, similar to figure 2, which is a recurrent network. Then also, additive attention neural network with pointing includes an encoder, an attention mechanism, a pointing mechanism, and decoder like the classical additive attention neural network. The decoder does not give feedback from the output layer to the hidden one, and the pointing mechanism is additive. The attention mechanism allows the decoder to focus attention on specific encoder output. The pointing mechanism allows the decoder to focus on specific encoder inputs. Let's not limit our consideration to the function of the n and the case when the encoder and decoder are based on n. It is assumed that the text input sequence equivalent has already been converted to an encoded input sequence, or and the length of each encoded word as the input sequence. It is assumed that an encoded output sequence of length will be converted to a text output sequence, and the length of each encoded word as the output sequence is equal to the number of hidden layers in the encoder and decoder is equal to n respectively. Function as the integration, calculation as the output signal for the hidden layer as the encoder. Checking the computation of encryption. Additive attention and additive attention is used, which connects the encoder's hidden layer and the decryption hidden layer. Calculation of weight, estimate of attention, context calculation, pointing, calculation of the output signal for the hidden and output layers as the decoder. Checking the computation of decryption. Criterion for evaluating the effectiveness of neural network translation model. In this work, for the training of neural network translation model, the criterion of model adequacy was chosen, which means the choice of such values of parameters that delivers maximum accuracy, the coincided of the model output and the desired output. Training of neural network translation model is subject to criteria. Methods for determining the values and parameters of neural network translation models based on the ADAM method. Let the weight vector be defined as, let the n energy error be defined as, let the vector partial derivative gradient be defined as, function. The vector if the first moment is calculated based on the exponential movement average. The second moment vector is calculated based on the exponential movement average. And the vector average is calculated traditional variant comes correct, gradient is calculated. Experiment and result. The numerical study and the proposed method for determining the parameter values was carried out in the Google collaboratory environment using the TensorFlow package to determine the structure of the modified neural network model, additive attention, multiplicative attention, additive attention is pointed with 156 input neurons. Determining the number of hidden neural several experiments will carry out the results which are presented in the figure 4. The standard data set SPA and was used as input data to determine the validity of the parameters of the neural network translation model. The data set contains 2,000 records. The criterion for choosing the structure of the neural network model was translation accuracy. For translation, it is sufficient to use 256 hidden neurons. Since this further increase in the number of hidden neurons, the change in the accuracy value is insignificant. Similar studies will carry out on the standard data set, and similar results will obtained. As can be seen from figure 4, with an increase in the number of hidden neurons, the accuracy value increases. Table 1 presents a comparative description of neural networks translation. Type 1 shows that modified additive attention response has a high translation accuracy. Conclusions. To solve the problem of improving the accuracy of the translation of linguistic structures, the existing method of neural network translation will against this study have shown that today is the most effective and the use of recurrent neural network. To improve the quality of the translation of linguistic structure mathematical model or modified neural networks, additive attention, multiplicative attention, and additive attention is pointed, will create analyze the corresponding additional neural networks in the decoder and the proposed modified neural networks. There are no feedbacks from the output layer to the hidden one. The decoder structure on the with the encoder structure is simplifies the practical implementation of the decoder. In the first numerical study of neural network translation models, their structure will determine the experiments performed shows that with 256 hidden neurons, the accuracy of value does not change significantly, and the selected network gives translation results with maximum accuracy. The proposed approach can be used in various intelligent systems that use translation of linguistic structures, for example, in computer system for supply chain management with natural language interaction between subjects